Today we're going to talk about Lesson 522, Generalizing Arithmetic Sequences. In Lesson 521, you learned to identify arithmetic and geometric sequences. Arithmetic were the ones where if you added a number each time you got the next term, or subtracted the number each time you got the next term. And geometric sequences were the ones where you multiplied or divided by the same number every time to get the next term. Today we are going to solve problems involving arithmetic sequences. Let's start with this first sequence. First of all, we want to know what type of sequence it is. So if you look and find a pattern, you'll see that when you go from 3 to 7, then you add 4. And when you go from -1 to 3, then you add 4. And when you go from -5 to -1, you add 4. And when you go from -9 to -5, you add 4 also. So since I am adding 4 each time, then I definitely have an arithmetic sequence. It's an arithmetic because its sequence generator is +4. I'm adding 4 each time. Now, when your sequence generator adds a number to each term, this also has another name. The sequence generator is 4, or we can say the common difference is 4. The common difference is the difference between each term and the term before it. All right, now the next thing they want us to do is they want us to record our sequence in a table. If you'll remember, instead of using x and y, we use n and t of n to do our table on a sequence. We always start with 1 because our first term in the sequence is always 1. So our first term in this case would be -9. Our second term would be -5. Our third term would be -1. Our fourth term would be 3. And our fifth term would be 7. Remember, n is always your term number, and t of n is always the value of the term, or when you have a list of the terms, those are the t of n's. So again, in this case, our first term, the value is -9. Okay. The next question, it asks, what is t of n when n equals 0? Well, we don't have n as 0 here, so right above it, we're going to put 0 right here. We want to know what would the value of t of n if we could have a 0 term. Because we need to know that, because when we write our equation, we want to be able to know what the starting point is. All right, so if we are adding 4 each time here, that is our slope. So when we go backwards to find the value of the 0 term, we take -9 and we subtract 4, so that would be -13. So we would say t of 0 is -13. When n is 0, the value is -13. All right, now we're going to graph the sequence. So I'm going to sketch my graph right here. And when we have an arithmetic sequence, do you remember what kind of graph we should have? Well, let's see. I need to go to 5 on the x-axis. 1, 2, 3, 4, 5. I need to go up to +7. 1, 2, 3, 4, 5, 6, 7. And I need to go down to -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so I graph. I go over 1, down 9. I go over 2, down 5. 1, 2, 3, 4, 5. I go over 3, down 1. I go over 4, up 3. And I go over 5, up 7. So remember, we do not connect the points with a line because whenever we have a sequence, it is discrete. We don't have terms in between 1 and 2 or between 2 and 3. We don't have term 1.5. So we will not connect the points with a line. Now, we want to write an equation for the nth term. To do that, to write an equation, what are the two things that we need to find? We need to find what m equals, and we need to find what b equals. Well, our slope in this case is our sequence generator or our common difference. So my slope in this case would be 4 because that is what I'm adding each time in my xy chart. My b is the 0 term, which is -13. And if I have those two pieces of information, I can write my equation. My equation, remember, we're not going to use y equals mx plus b. We're going to use t of n for y, and we're going to use n for x. So instead of y equals, I'm going to say t of n equals my slope, which is 4, times x, but in this case we're using n, and then my b is, or my starting point, is -13. So there is the equation of my sequence. One thing I wanted you to find in this case is the domain. What is the domain for this sequence, or any sequence? If our sequence always starts with term 1, our n is always 1 to begin with. That's where we're going to start. So the domain would be all integers that are greater than or equal to 1. So 1 is always first, and then it's 2, 3, 4. It's the same every time. You'll never have, your domain won't have any fractions or decimals in it, and it won't have any negative numbers when you're talking about a sequence. The last part of this problem, it asks, how is the common difference related to the graph and the equation? Well, we learned that the common difference, which is our sequence generator, is also our slope. So our common difference, how is it related to the graph and the equation? It is the slope. It is the number in front of n in the equation, and it is our slope when we go from one point to the next. We go up 4 over 1, up 4 over 1, up 4 over 1. All right. So basically, the main thing you needed to get from that problem was how to find the sequence generator, that the common difference is the same as the sequence generator, that we can make an XY chart, in this case, n t of n chart, and we can graph it, and we can find the equation. Next problem. On this problem, we have another sequence, and it wants to know, first of all, what the first term is. The first term, in this case, we would say t of 1 is -4. Then it might ask you what t of 0 is. Well, t of 0 means I'm going to go backwards. Well, to do that, I have to find my sequence generator, or my common difference. Here I'm adding 3, here I'm adding 3, here I'm adding 3. So if I'm going to go backwards, I'm going to subtract 3. So what would my t of 0 be? If I subtract 3 from -4, I'm going to get -7. So t of 0 equals -7. What is the common difference? And we'll have to abbreviate that so I don't have to write that out every time. The common difference is 3. All right, on the next part, they want us to write an equation. So do we have enough information to write the equation? Well, m and b. We know m is the common difference. It's how much it's growing, so that's 3. And b would be my 0 term, so that would be -7. So my equation would be t of n is equal to 3n minus 7. Now, it wants me to check that and make sure that that equation is correct. And to do that, you can do a little NY chart or N T of N chart and check yourself. Well, in this case, our first term, let's plug it into the equation. If we plug in 1 for n, what's 1 times 3? 3 minus 7 would be -4. And you'll notice that that is the first term that I have up here. My second term, let's use our equation to find it and see if it checks with what our original problem was. If I plug in 2 for n and multiply by 3, I get 6. And 6 minus 7 is -1. And there's my second term. If I plug in 3, I'm trying to find my third term from my equation. I can plug in 3 right here and say 3 times 3 is 9, and 9 minus 7 is 2. And I get my third term. And then if I want to check on this to make sure it gives me my fourth term, I put my 4 in for n. N stands for the term number. 4 times 3 is 12, and 12 minus 7 is 5. And that is that term there. So we know our equation is right because when we plugged in the term numbers, 1, 2, 3, 4, into the equation, it gave us the correct term numbers. Now, on this next part, it's going to ask you if or can t of n equal 42. That means if I continue down, would I eventually get to 42? Well, I don't want to do that on my XY chart, but I can use the equation to help me. So let me write my equation down again. I have t of n is equal to 3n minus 7. And I want to know, is it possible for t of n to be 42? Well, that means if t of n equals 42, I would replace the t of n in my equation. So I'm going to put 42 right here, and I'm going to see if this is possible. How do you think we are going to be able to tell if this is possible or not? Well, let's solve this equation for n and see what we get. I am going to add 7 to both sides, and I get 49 is equal to 3n. And when I divide by 3, does 3 divide into 49 evenly? No, I get a fraction or a decimal. Now, that's saying that n would have to be 49 over 3. I'd have to have 49 over 3 to get 42 over here. Is that possible? The answer would be no. Why? Because the domain is only positive integers. N can only be positive integers, no fractions. So if it asks me, can t of n equal 42, and I plug it into the equation and I get n as a fraction, I have to say no, that is not possible because I cannot have any fractions in this n column right here. All right, moving on. It says, the next part, it says for that function. So I had the sequence t of n is equal to 3n minus 7. But what if I have the function f of x equals 3 of x minus 7? Can f of x equal 42? So this is a sequence, this is a function. If I substituted 42 in for f of x, I would get 42 is equal to 3x minus 7. I would add 7 to both sides, and I would get 49 equals 3x, just like we did before. And I would get x equals 49 over 3. Is that okay? Can f of x equal 42 if x equals 49 over 3? Well, the answer to that would be yes. F of x can equal 42. And that means that when that happens, x equals 49 over 3. That is okay because the domain of a function that doesn't have any fractions or any restrictions on it is all real numbers. If I have this function right here, I can plug anything in for x that I want. I can get fractions, I can get decimals, I can get negative numbers. So, if you have a sequence and it says, can this number be a term? You're going to plug it in, and if you get a fraction or a decimal or a negative, you would have to say no. If you have a function where it's in this notation, you can get a fraction or a decimal. We get fractions and decimals all the time when we were dealing with functions. That is okay. Restricted domain for a sequence is you have to start with 1, and it can only be integers that are positive. All right, the last part, T of n. You have a sequence. The domain for any sequence is limited to positive integers. For f of x, you have a function. The domain is all real numbers. Okay, moving on. We have a little story problem here. It says, Trixie wants an especially tricky arithmetic sequence. She wants to create one. She wants the 5th term of the sequence to equal 11 and the 50th term to equal 371. That is, she wants f of 5 to equal 11 and t of 50 to equal 371. Is it possible to create an arithmetic sequence to fit her information? If it is possible, you want to find the sequence generator, the initial value of t of 0, which is your starting point, and then find the equation for the arithmetic sequence. If it is not possible, explain why not. Okay, so on this story problem, if you guys would like to try this first, before I show you how to do it, you could stop the video, pause the video, and try it yourself. I have a feeling, though, that since this is our first story problem like this, that you will probably want to just do it along with me. All right, let's write down what they gave us. She said she wants the 5th term to equal 11. So we're going to say t of 5 is going to equal 11. And she wants the 11th term, she wants the 50th term to equal 371. So t of 50 is equal to 371. And they gave us that in the problem right here. It says, is it possible to create an arithmetic sequence to fit our information? Well, what did they just give us? Well, if we put this in an XY chart, we have n and t of n. Well, when n is 5, the term is 11, and the 50th term is 371. We actually have 2 points. We have 5, 11, and we have 50, 371. If we have 2 points, and we are trying to find the equation, what do we have to find? Well, we have to find m and b. If we have 2 points, we can find the slope by using our slope formula, which is y minus y over x minus x. So if I take 11 minus 371 and I put 5 minus 50 on the bottom, I have y minus y over x minus x. When I simplify that, I get negative 360 over negative 45. And when I do that on my calculator, my negatives cancel and I get a positive 8. So my slope is 8. It did say, let's see, it said, if it is possible, find the sequence generator. Well, we just found our sequence generator is 8. Okay. We want to find t of 0. Well, to find t of 0, that's our starting point. So if we know this and we have 2 points, we're going to use y equals mx plus b. Now I know we're not supposed to use y equals mx plus b, but we're going to use it to find our b, just knowing that really this is t of n is equal to mn plus b. So we're going to pick a point. I say let's pick the small point and let this be x and this be y. Or this is n and this is t of n. So here under the y or under the t of n, we're going to put 11. Our slope is 8. And our n in this case is 5. If we can solve this equation for b, then we will have our starting point, or our 0 term. So we have 11 equals 40 plus b. Subtract 40 from both sides. And I have b equals negative 29. So we found our sequence generator. It said to find our initial value, our t of 0. Our t of 0 is our starting point, which is negative 29. That is also our b. And now it wants us to find the equation. So to find the equation, again, we're going to use these two formulas. T of n equals our slope, or sequence generator, which is 8, times n, and our starting point, which is negative 29. So they gave us 2 points. If we have 2 points in our sequence, we can write them as ordered pairs. We can use our slope formula to find the sequence generator, or our slope. And then we can use the y equals mx plus b to find our b, which is really our starting point. Which is really our starting point right there. Okay? Next problem. It says Trixie is at it again. This time she wants an arithmetic sequence that has a graph with a slope of 22. So let's write that down. Our slope is 22. She also wants t of 8 to equal 164. And she wants the 13th term to have a value of 300. Is it possible to create an arithmetic sequence to fit her information? If it is possible, find the equation. If it is not possible, explain why not. Well, again, we have 2 points. Let's write them as points. We have 8, 164, and we have 13, 300. All right, so if we wanted to know if we can possibly get that has a graph with a slope of 22. So if we could take these 2 points and find the slope, hopefully it's going to equal 22. If it doesn't equal 22, then it won't be possible to create an arithmetic sequence to fit her situation. So let's try it. Our slope would be 164 minus 300. over 8 minus 13. Our slope would be it would be negative 136 over negative 5. So therefore our slope would be, if I do that on my calculator, I get 27.2. That is not 22. So is it possible to have a slope of 22 when it goes through these 2 points? And the answer would be no. So it is not possible. The slope could not be 22. Okay? All right, that one was pretty easy. Let's go on to the next one. This is the last one that I'm going to work from the lesson, and we're only going to do part A. It says, find the equation for each arithmetic sequence represented by the tables below. So all we want to do is find the equation for the arithmetic sequence here. Now, you'll notice that these are kind of all mixed up. Okay, so we're not going to be able to find the slope by just looking at our chart. So what I would do is, in fact, if you guys want to try this one, you could pause right here and try this one, see if you can figure it out. If not, the 2 points that we're going to talk about, I'm going to pick this point and this point, just because they're the first two. I could pick any of those 2 points, but I'm going to use 754 and I'm going to use 310. And if I pick 2 points, I can find the slope. And if these are all in the sequence, then it shouldn't matter what 2 points that I use. So to find the slope, I'm going to say 54 minus 10 over 7 minus 3. Well, 54 minus 10 is 44, and 7 minus 3 is 4. And when I simplify that, I get 11. So my slope equals 11. But to write the equation, I have to also find b. So again, I'm going to use, even though I'm not really supposed to use y equals mx plus b, I'm going to write that one down. And I'm going to pick one of these points. I think I'm going to pick this one. This is my x and this is my y. So my y is going to be 10 is equal to the slope, which is 11, times my x, which is 3, plus b. I get 10 equals 33 plus b. Subtract 33 from both sides, and I get b equals negative 23. So do I have enough information to write my equation of my sequence? Sorry about that. Let's see. My sequence. So I know I'm using t of n. My slope is 11. I'm using the letter n instead of x, and I say minus 23. There is the equation of the sequence that is represented by that n t of n chart. Okay, now the last thing I would like to do is, these are the first 2 problems in your homework, in your review preview. So we're going to determine whether 447 is a term of each sequence below. I just wanted to work a couple of these with you. There's 3 more after this, so you'll get to try it yourself too. But I just wanted to be clear on what you would do. It says determine whether this is a term. So they're wanting to know if this is a term, which means, is it in the t of n column? If so, which term is it? So if it is a term, I want to know what term it is. So, part A. If I want to know if this is a term, that means that, let me write this down, t of n, is it possible for t of n to be 447? So what I'm going to do is I'm going to put 447 in for t of n and check it. So I'm going to put 447 in for t of n equals 5n minus 3. Do you remember how we tell if it is actually going to work or not? Well, let's solve it and see if we can remember. We worked one of these earlier. If I add 3 to both sides, I'm going to get 450 is equal to 5n. And when I divide by 5, I get n equals 90. Is that okay to have an n of 90? It's positive, and it's greater than 1, and it's not a fraction, it's not a decimal. So we would say yes. 447 is a term in the sequence. It is the 90th term because we found out that n equals 90. We could say that t of 90 does equal 447. Let's do the same thing with this one. Try it again. Is 447 a term in this sequence? So we're going to put 447 in for t of n again, and we're going to solve for n. Subtract 24 from both sides. I'm going to get 423 equals negative 5n. When I divide by negative 5, I get n equals, and when I divide that on my calculator, not only do I get a negative, but I also get a decimal, 84.6. Can you have, in the n column of a sequence, can you have a negative number or can you have a decimal? The answer would be no. You can't have a negative or a decimal as the term number. So 447 would not be in the sequence. And that's how you do the first 5 problems in your homework. That is all for today.